All right. So what we're doing is we're looking at the proportionality on how the centripetal force for an object moving in a circular path changes. So you have your equation, centripetal force is equal to the mass times your tangential velocity, linear speed, they all mean the same thing, divided by the radius. Now they're going to tell you something like, hey, the centripetal force is 10 newtons. If I double the mass, what happens to the force? If I double the velocity or speed, what happens to the force? If I double the radius, what happens to the force? If I triple something, if I cut it in half, what happens? So the easiest way we can do this is take each of these letters and make them a 1, but keep them in the same place. So m would be a 1. Velocity or speed would be a 1, but you have to square that. And then the radius would also be a 1. So the first thing would be, what would happen if we double the mass? If the mass is doubled. Okay, well, if the mass is doubled, you see the 1 here? All right, you go to the one that is in place of the variable that's changing. Since m is that first one, we're going to take this m, right, this 1, and we're going to do what to it? Instead of it being a 1, we're going to make it a, what do you think? 2. All right. They didn't tell us anything else changed. So the speed stays a 1, but you still square it. And they didn't tell us anything about the radius. So that stays a 1. All right, you can even throw it into your calculator if you would like to. That's fine. 2 times 1 squared equals 2. Divide that by 1, it's 2. So this is going to make us 2 times the force. If the original force in the problem they told you was 10 newtons, well, then you're going to do 2 times 10. 2 times 10, 20 newtons. So if you double the mass, what happened to the force? It doubled. Therefore, if they said the mass is tripled, instead of a 2, right, we'd turn the 1 that's the mass, we'd make it a 3 and play this out. And it would be 3 times the force. If they said 4 times the mass, well, this would be a 4, and everything else would work out. It would be 4 times the original force, and then we would wind up with 40, etc. So that is a directly proportional relationship. Mass is directly proportional to the centripetal force. Anything that happens to the mass is going to directly cause the force to change accordingly. If you double the mass, all right, force doubles. If you cut the mass in half, the force should get cut in half. Now, what happens if the radius is doubled? If the radius is doubled, did they say anything about the mass or the speed? No, so we're going to keep them 1s. The 1 that's in place of the radius, though, the 1 that's in place of r, says we got to double it. So we're going to double it. Again, if you wanted to throw this into a calculator, you can. 1 times 1 squared equals, divided by 2, we get a half of, all right, we get 0.5. So 0.5 times the force. If the force was 10, we substitute 10 for Fc. So 0.5 times 10, 5 newtons. So we doubled the mass, the force got, we doubled the radius, the force got cut in half. They're the opposites. So if we tripled the radius, all right, if we made r a 3 instead of that, 1 times 1 squared equals this, divided by 3, all right, and then take that answer, times it by 10, we would be 1/3 of the original force. If it was 4, take 1 times 1 squared, divided by 4, and then multiply that by the original, you would wind up again with 1/4. So instead of where mass, whatever happened, it doubled, the force doubled, it tripled, the force tripled, radius is the opposite. Whatever happens to the radius, the opposite happens to the force. That is an inverse proportionality. Okay, so we've seen mass, we've seen radius, but what about our speed? What about our tangential speed, linear speed? Well, the mass doesn't change. So this m, all right, the 1 that's in place of m, we keep it a 1. The 1 that's for speed or velocity is changed. So we're, instead of it being a 1, we're going to make it a 2. You square it. And they didn't tell us anything about the radius, so we leave that a 1. Okay, again, you can throw it into a calculator if you need to. 1 times 2 squared is 4, but we got to divide by 1 on the bottom. That doesn't change it. It's going to be 4 times the force. The original force was 10, so 4 times 10 gives us 40 newtons. Whoa, whoa, whoa. So we doubled the speed and the force increased by 4. Yeah. Why, though? Well, you see how the speed is squared? So whatever we do to the, right, whenever we increase our speed, the force is going to increase by the square of that number. So instead of this being a 2, if they said the speed was tripled, well, we would have 1 times 3 squared. Divide by 1, 9 times. Okay? 1 times 4 squared, it would be 16 times as much force. If they increased it by a factor of 5, 25, all right, etc. Okay, so we've seen what happens when we increase each of these. Well, what happens if we decrease them? What if the mass is cut in half? What if the mass is cut in half? So we can just use 0.5 for it. So the 1, that's m, if that is 0.5, right, 0.5. They don't tell us anything else changed, so this is a 1 squared, this is a 1. Pop it into the calculator. 0.5 times 1 squared is 0.5. Divide that by 1. It's still 0.5. 0.5 times the force. So 0.5 times 10. 5 newtons. So when the mass got cut in half, what happens to the force? It went from being 10 to 5. It got cut in half. Again, directly proportional. Whatever the mass does, the force is going to follow. Right? When we have a problem like this. Okay, so if the mass got cut into, if they said the mass was 1/3 of the original, well, we'd have like 0.33 here, repeating. Okay, times it, it would be 1/3 of the original, etc. What about if we change the radius, the radius, the radius? If that, John, is halved. Okay, so someone tell me then, what number am I changing?
The 1.
Which one? Because we got 1, 1, and 1.
Second.
This one? So let's get first, second, third. Which one are we going to change?
Second.
This one right here?
Yeah.
Well, that would go for V.
Oh.
So which one would we wind up changing? The one that goes for,
The bottom.
yep, for R. So since the radius is the one that changed, mass is going to be a 1. Velocity is going to be a 1. But the radius is going to be cut in half. So that's going to be a 0.5. All right, now if we throw that into the calculator, 1 times 1 squared divided by 0.5, that is actually going to give us 2 times the original force. 2 times the original force of 10 is going to give us 20 newtons. So when we doubled the radius, the force got cut in half. When we cut the radius in half, the force doubled. They're the opposites. All right? So mass is directly proportional. What happens to the mass happens to the force. Radius is inversely proportional. So they're kind of opposites. So if I triple the radius, the force gets cut into a third. If I cut the radius in half, well, then the force is going to double. Okay, well, what about if we cut the velocity in half, or speed in half? All right, which one are we changing now? Are we changing the first, second, or third? Well, the first one's for mass, so we're not changing that. Right. The second one is v, which is our linear speed. So yeah, we're going to change that one. So 0.5, and but we have to square it. And they didn't tell us we could change the radius, so that 1, we're going to leave a 1. Okay, and then you can throw it into the calculator. 1 times 0.5 squared equals 0.25. Divide that by 1, you're still left with 0.25. So 0.25 times the original force. What was the original force again for this problem? 10. Good, so we're doing this times 10. And it's going to kick out an answer here of 2.5 newtons. All right, now I just got one more question. This one is not necessarily going to be on the next assignment, but you may see this on a quiz. All right, so we have mass, speed, radius. All right. Double mass, double speed, and what other number? What should we do with the radius? Double, triple, 4 times? What do you think? Triple. All right. And originally our FC would be 10 newtons. Let's see what happens. So the mass, the 1 for mass, if we double it, that 1 would become a 2. What about speed?
2.
It would be a 2, but what do you have to do with speed?
Oh, you have to square it.
Good, you got to square it. And then we said triple the radius, so the 1 that's an R would be a 3. Okay, let's throw it into the calculator. 2 times 2 squared is 8. 8, and then we divide it by 3. So it would be 2.6 repeating. All right, so we can go 2.6, call it 2.67 times the force, and I'm just going to take this and times it by 10. All right. So we'd be left at 226. If we round this to 2 decimals, 26.67, or round it to 1 decimal, 26.7. And that would be how you would complete those proportionality problems. All right, now your assignment that you're going to be going up, one of the problems that you're going to be doing, you're going to have questions like these. All right, you show the work just like this, but look for it. Mass is doubled, radius is doubled, linear speed doubled. Okay, it looks like this. The centripetal force for an object is 8 newtons. What if the mass is doubled? The force would be what? Hey, here's our first problem. The mass is doubled. Okay, if the mass is doubled, so you would do pretty much what we just did. Mass doubled. So if mass is doubled, this 1 that goes for M would be a 2. Everybody else didn't change. So this would be 2 times the force. And what's 2 times our original force in this problem is 8. What's 2 times 8?
16.
All right. When you get to this problem, it was how I showed you guys up on the board from the notes. Okay. Bless you. They're going to ask you to rank them as far as the rotational speed and tangential speed. So just like those horses on the merry-go-round, they're all on that same rail. As they rotate around, they make the same amount of laps. So they have the same amount of rotations, so the rotation speed is the same. But if you look, all right, like the overhead view, all right, the horse on the outside has to cover the most distance. So because of that, they would have the greater tangential speed. So D would have the most, then C, then B, then A. Okay, and the back side is just your definitions, which you should have gotten from the notes. Okay, guys? So come up, grab one of those, get to work, show me it when you have it completed.